So right now we're building the current wall panels, the structure, and we're also updating the massing to get us the floor areas as well. So as you can see, when we update the script, all the drawings here are updated all at the same time, just through what Revit normally does. And so this is the workflow for this particular part, where the enclosure design is done in the designer's model, which is the Rhino Grasshopper, and the core design, which is more regular and requires more technical information, is done in Revit with documentation tool. And these both talk to a central database that then relate to each other. It's based on the core design, you can affect how close the enclosure can taper, and how much the enclosure taper is going to affect how the core is designed. So the idea is to have this integrated data model that speaks to both sides at the same time, and that way the final model is more coordinated, and it's a better design in the end. Here, you want to talk about this part?
So you may be wondering, like, why do we even get through the whole trouble of having two different platforms? I suspect most people will say, well, why don't you do it just all in Revit, right? But one of the problems that I want to demonstrate is we don't always build geometrically perfect solutions, right? And one of the things that we always do when we have a geometrically complex building is we have the ideal form that we think that's the form it should be, but typically we do a couple of layers on top of it to kind of reduce the number of unique panels, where we we move a panel just a little bit so we can use the same panel in two different places. And so these types of analysis are really hard to do within Revit, and that's where we need other platforms. But then we don't want to we don't want to manually rebuild the model, and this is where this idea of linking all of this stuff